Be a good review maybe at the end of the class hour if you're viewing this video. The octet rule. The octet rule is something that basically is going to help us stable. So what it's saying, when you hear the word oct, you should start thinking 8. So all atoms want 8 valence electrons. The reason why is to become stable. So that's what makes them stable, is having 8 valence electrons. Now, with everything in chemistry, there's always an exception. There's several elements that are pretty satisfied with 2. We call that the duplet rule. And those particular elements are hydrogen and helium, always are satisfied with 2. You can also have lithium, beryllium, boron, occasionally carbon type of things will fall into this exception also. But for this class, if you know that hydrogen and helium are completely satisfied with 2, so they only want 2 valence electrons, you'll be okay. So the oxidation number is something that's going to be very helpful for us also. So this chapter, we just kind of want to introduce it to you. And basically, it's the charge. So as you're gaining and losing electrons, we're creating this charge. And it's our oxidation number. Now, there's a certain number that we want to get. So if you look at it, and you want to write this down, how many electrons an atom will gain, lose, or share to become stable? So remember, to become stable, all atoms want 8 valence electrons. With the exception of they want 2. So we have to look at the number of valence electrons in each group and decide, do they want +1, +2, and stuff like that. So we're pretty satisfied there. Okay, so let's look at this part right here. I'm going to escape out of this. I'm going to drag this up here. Actually, let me go back a couple slides here. If you look at this one may be a better one to look at. So on this slide, 1 has 1. And you have to ask yourself, do you want to get to 8? So is it easier to lose 1, or is it easier to gain 7? It's easier to lose 1. So if you lose an electron, what does your charge become? Remember, they're always neutral, so if you lose 1, no matter what it is, we're going to get a +1. Group 2, all those elements have 2 valence electrons. So they can either lose 2 or gain 6. What's easier? Obviously losing 2. So you lose 2 electrons. So you lose 2 electrons, and you're going to get a +2 charge. So those are our oxidation numbers. Okay? There are other oxidation numbers that are possible, but we're going to focus primarily on charge. When you get to group 13, they have 3. So it's easier to lose 3 than it is to gain 5. So we get +3. When you get right here, we've got 4. I can just as easily gain 4 as it is to lose 4. So I'm going to call that as ±4 from the oxidation number. Group 15, they've got 5 valence electrons. So I can gain 3 or lose 5. It's easier to gain 3. So if I gain 3, my charge becomes -3. Over here I've got 6. I want to gain 2 more, -2. 17 -1. Then when you get over here to these guys, okay, all these have 8 valence electrons, the exception being helium, which has 2. So they don't want to gain or lose any. So their charge is 0. So my oxidation number would be 0 for that particular element. So if you see the pattern here, group 1, group 2 has 2, go to 13, +3, 14 ±4. Then we start counting backwards, -3, -2, -1, 0. And then we get our final answers. Okay, we've covered those, so let's skip ahead here just a little bit. Okay, so if you look at this right here, let me escape out of that and pull that down just a little bit. Okay, so if you're in group 1, they have one valence electron, we want to lose it, so we're going to get plus 1. Group 2 has 2 valence electrons, we're going to lose it, we get plus 2. Group 16 has 6 valence electrons, we're going to gain 2, so that becomes minus 2. Calcium is in group 2, so it's got 2 valence electrons, we want to lose those 2. Phosphorus is in group 15, so it has 5 valence electrons. So I need to gain 3, so I'm going to put minus 3. And argon's in group 18. It has 8 valence electrons, so we're going to have 0. Another way of looking at this is I can say calcium has 2 extra electrons. I put plus 2 to show extras. Negative 3 for phosphorus says it's missing 3 electrons. So you can use that to help you out if you need something else to remember it by. So last slide here that we need to look at. Elements in the same group tend to have the same number of valence electrons. Elements with the same number of valence electrons tend to have the same oxidation number. So if you keep that in mind, that'll kind of tell us of the reactivity. So elements in the same group will have the same reactivity. All right, so this video is going to be posted on YouTube, so you can take a look at it anytime you want. You can pause it, fast forward it, kind of jump around a little bit, and do that type of thing. As promised, I'll also go back here and show you this little video that kind of just summarizes, oh, went too far, our ions.